Okay, yesterday we learned how to solve equations involving fractions. And we had one, like question 1a, where we have 1/3 times x take away 2 equals 5. And what we learned was that we would multiply 3 on both sides of the equation in order to eliminate the denominator 3. So we would take this denominator of 3 and essentially multiply it up to the other side. What that does is it eliminates the 3 from where it is right now. So we would be left with a 1 times x minus 2, and on the right hand side would be 5 times 3. Okay, so all we've done is multiply the 3 up to the other side. In the same sense, we multiplied both sides of the equation by 3 to eliminate the denominator 3. Well, this 1 in front of the brackets, actually 1 times anything is itself. So it doesn't really need to be written there. So essentially what we have in this next line is x minus 2 equals 15. We then have to isolate x. We bring this subtract 2 to the other side, which is add 2. When you change sides, it changes operations. So instead of subtract 2, we are now adding 2. So the only thing remaining on the left-hand side is x. On the right-hand side, we would have 15 plus 2, which of course is 17, and that would be the solution. Okay? Conversely, we solved this equation in a little bit of a different way when we looked at the strategy of multiplying both sides by 3 to eliminate the fraction. So what we would have done is we would multiply this side by 3 and this side by 3. Essentially, we get the same thing because these 3's eliminate each other. 3 divided by 3 is 1. And then, of course, we are left at the same line where we were just below. The 1 in front of the bracket doesn't mean anything because it's anything multiplied by 1 is itself. So again, we're at this same situation where x minus 2 equals 15. Now, the other strategy that we used the other day was, instead of using the arrows, where we're bringing the plus 2 over, what we simply did was added 2 on both sides of the equation. So it balances the equation. What you do to one side, you must do to the other. That's why we multiplied by 3 on left side and right side above. So essentially what happens then now is that the negative 2 plus 2 is now 0. It cancels out. So what we have is x equals 17. So whatever strategy you like to use, you can use the arrow method or you can use the balance method. Either works perfectly fine. Today what we're going to look at is questions like questions 3 and 4, where there's a fraction on both sides of the equation. I'm going to just pick an example from the textbook and we can go from there. So an example would be if we have x plus 2 over 3 equals x minus 4 over 5. So notice we have an example, a fraction on both sides of the equation. What we want to remember is the LCD. The idea of what an LCD is, which is the lowest common denominator. What would be the lowest common denominator between 3 and 5? Well, I can count by 3's, or I can list all the factors of 3, which are 3, then 6, then 9, then 12, then 15, etc. And I can list all of the factors of 5, or I can count by 5's, 5, 10, 15, etc. And what I notice is that 15 is common in both of these. Okay? If 15 is common in both of these, then that would be the lowest common denominator between the two. So the strategy here is to multiply both sides of the equation by the LCD 15. So that's exactly what we're going to do. We're going to take the left side of the equation and multiply it by 15. We're going to take the right side of the equation and multiply it by 15. Again, I like using a different color here because it really highlights what you're trying to do and it doesn't confuse. If you use all black or all pencil, it kind of blends in, right? Now what we're going to do, I'm going to choose another color again because what we have is we have a multiple of 15 and then we have a denominator of 3. You'll notice what I'm doing in blue. The 3 and the 15 cancel each other out. What's 15 divided by 3? Well, it's 5. On the other side, I'm going to cancel the 5 and the 15. What is 15 divided by 5? 3. Okay? So what ends up happening, by multiplying by the lowest common denominator, you've eliminated both fractions. You eliminated the 3 and the 5, which are causing an issue in terms of the completing the problem. So on the next line, I will write the equal sign first to balance it out. On the left-hand side, I still have my x plus 2 there, but I have that blue 5, so I have to multiply the x plus 2 by 5. So in order to show that, I must show the distributive property happening. The 5 has to multiply by every term on the left side. Same on the right side. I have my x minus 4, okay, but I have to multiply that by the 3, the blue 3 that's above. I'm going to write it in front just so it looks normal. I could write it after the bracket, but it doesn't matter what order you multiply in, so I will just put it at the front. Okay, so now you can see what's happened here. We have the numerator of x plus 2. We have that blue 5. They have to be multiplied together. So I'm going to show the multiplication by using a bracket, and hence the distributive property. That's the next part. Of course, the 5 multiplies by the x and multiplies by the 2, and 5 times x is 5x. 5 times 2 is 10. It's positive, so I'll write a plus sign in front of that. Likewise, on the right side, I have to use the distributive property to multiply in. So the 3 has to multiply by the x to give 3x, and the 3 has to multiply by that negative 4, which gives us negative 12. And that negative sign just gets used as a subtraction sign on this row. So I can read that whole row as 5x plus 10 equals 3x subtract 12. Now we use the balancing technique again. We want to isolate x. So if you're following my strategy in class, I like bringing the variables to the side with the largest number or coefficient. So as you can see, 5x is larger than 3x. So what I would like to do is bring the 3x over with the 5x, right? Seeing as 5x didn't have to move, it remains on the left-hand side, I write it first. When I bring the 3x over, I'm bringing it over as a subtract 3x. Right? I have to change the operation. Right now there's an invisible positive sign in front, so when I bring it over it turns into a negative. So there's the negative 3x. Excuse me for a minute. I'm back. Okay, so I've determined that I'm going to bring my variable terms to the left side because 5x is larger. That means that the constant terms are going to go to the right-hand side. So on the right-hand side right now, the only constant term I have is negative 12. So I'm going to write that first. I always write the number that doesn't move. I write it first. On the left-hand side, I have this positive 10 that I'm going to swing across the equal sign and bring it over with the other constant term. And you can see when I change sides, I have to change signs. So I'm going to change the operation from a plus 10 to a minus 10, and I just write it and tack it on at the end. Now I have grouped all of my like terms on either side of the equal sign. I keep my equal sign lined up, so I draw that first. Okay, and now I am ready to just subtract, or it's basically a lesson in integers. 5x minus 3x is 2x. Negative 12 minus 10 is negative 22. And now we're at the step where we can look at this and just say, well, 2 times what number is negative 22? Or we could actually carry out the algebraic part of this. It's 2 that's multiplied by x, so in order to bring it across the equal sign, I have to do the opposite operation, which is divide by 2. What I do to one side, I must do to the other. So by dividing by 2, what that does, 2 divided by 2 is 1. So what I'm left with is 1x, or just simply x. And on the right-hand side, I have negative 22 divided by 2, which is negative 11. And now I've completed my problem. I'm going to try one more example here. And this will help as well. I have 1/3 multiplied by 2x take away 5. And I have 3/4 multiplied by x minus 2. So here's an example, and it's very much like the last example. It just looks a little bit different. Instead of having the whole 2x minus 5 as a numerator, now there's a coefficient in front. There's a number in front being a factor of 1/3. So what we're going to do, off to the side, we're going to find the LCD. We could list all the factors of 3, 3, 6, 9, 12, etc. Right? And we can list all the factors of 4, account by 4, 4, 8, 12, 16, etc. We could do it that way and just decide, oh, I see my lowest common denominator. Well, it's 12. Both 4 and 3 go into 12, and that's the lowest one on that list, so that would be it. So it's the same strategy as last time. I'm going to use that lowest common denominator. I'm going to multiply 12 on both sides of this equation. I'm kind of squishing it in there. Maybe I should have used a new line. Okay? In any case, I could leave it, just like this, and I could get out my blue pen and cancel it off like I did in the last one. But I just want to show you why you can cancel it off. In the first part, on the very far left, we have 12 times 1/3. Well, this 12 is over top of an invisible 1, right? So when we multiply these two fractions together, I have, in the numerator, I have 12 times 1. And in the denominator, I have 1 times 3. I still have that 2x minus 5. On the right-hand side, it doesn't look as clear and straightforward, but I'm multiplying by 12 on the end. I can multiply by 12 on the front too. It doesn't really matter. The order of multiplication doesn't matter. So I could take, in this case, 3 times 12 as the numerator. So on the right-hand side, since it doesn't matter what order I'm multiplying in, I can just change the order of multiplication. So the 12 is over top of a 1, so I'm going to multiply it by 3. 3 times 12 is 36. That's my numerators multiplied together. And my denominators, 4 times 1. And I still have that factor of x minus 2 in brackets, just sitting there waiting to be utilized at some point. Okay, so we talked about how things can be canceled in that last question. I did use a blue marker, so I'll do the same here. 12 and 3. 12 divided by 3 is 4. On the right-hand side, I have 4 and 36. Well, 36 divided by 4 is 9. Okay, so that's why we can cancel it out like I did on the previous slide. So what's remaining? Similar to the last one where I have that 4 in front. There's my 2x minus 5, so I still have to keep it in brackets because I have to use distributive property. I have the 9 and x minus 2. Okay, so now I'm showing that I'm going to be using the distributive property, and I show that by using arrows here, just to show that I'm multiplying in. I'm going to multiply that 4 into both terms. So 4 times 2x is 8x, and 4 times negative 5 is negative 20. Likewise, on the other side, distributive property, 9 times x, 9 times negative 2. So 9 times x is 9x. And 9 times that negative 2 is negative 18, and the negative just gets written as a subtraction sign in that line. So again, I'm going to look at this equation. I'm going to decide, well, which one, where am I going to move my variables? Where am I going to move my constant terms? Well, I can see 9x is larger than 8x. So for me, that means that I'm going to move my 8x over to the right-hand side. That way, I don't end up with any negatives. That's what I try to avoid. Okay, seeing as 9x is not moving, I write it first. That's just what I like to do. And because I'm bringing that 8x over, I'm going to bring it over by using subtraction, because right now there's an invisible positive sign in front of it. So when I change the sides, I change the signs. So it becomes a negative 8x. On the left-hand side, I have a constant term of negative 20, and I'm not moving that. So I'm going to write it down first. And what I'm doing is I'm bringing this negative 18 to the left-hand side to join it. When I bring it over, it's going to turn into a plus 18. I'm running out of time here. As you heard, the bell just rang, and it's going to get loud in here. So I'm going to just finish this up. Equal sign, 9x take away 8x is 1x, or just x. Negative 20 plus 18 is negative 2, and that concludes my answer. X equals negative 2, basically. Okay, and we're all done. You will be continuing on with questions from page 208 to keep you busy today. And on page 208, we are looking at questions 3 and 4, 6, 10, and 11A. And now I see that 8 didn't write it very well. Page 208, number 3, 4, 6, 10, 11A. Good luck.